In this video, we're going to take a look at testing a claim about two dependent samples, right? So here we have samples that are dependent. We will call those matched pairs. And so when we have matched pairs, we are looking at two data values or two sample sets where a value in the first sample set is somehow naturally linked to a value in the second sample set. So you can think about things like before and after measurements. You can think about items where you have left and right, top and bottom, values that just are naturally paired together. So here what we want to do in this process is we want to calculate the difference between each of the matched pairs. And then when we compare the matched pairs, the null hypothesis is that the mean difference is equal to 0, right? So our null hypothesis is we use mu sub d to be the mean difference. Right? So the mean difference, if we look at all the differences between all of the pairs and find the mean of those, the null hypothesis is that that mean is equal to 0. Then the alternative hypothesis is either that it's not equal to 0, that it's greater than 0, or that it's less than 0. And so with the greater than 0, you're saying that the first value in those ordered pairs appears to be greater. If the mean difference is less than 0, you're saying the second value in those ordered pairs appears to be greater. When you say it's not equal to 0, you're just saying one of them is greater, whichever one it happens to be. You're not specifying that. For this, for our hypothesis test for matched pairs, the process is really to deconstruct this into something like a mean hypothesis test like we had before. That's why we're taking the differences, and so D is the difference between two values in a single matched pair. And so we get all of these differences, and then we're making a hypothesis about the mean of all of those differences. So D bar, that is the sample mean from all of those differences. N is representing the number of pairs, and S sub D is not the standard deviation in an individual, but it's the standard deviation among all of those differences. Here, when we go through this process, we have a t distribution, and our degrees of freedom is n minus 1, where, again, that value n is the number of pairs. Right, so it's 1 less than the number of pairs. Our confidence interval here is calculated in this way, where the margin of error is this right here. Beautiful. When we go about interpreting this, we again ask ourselves, when we go about interpreting the confidence interval, the associated confidence interval, we ask, does that interval contain 0? If it does contain 0, then it's reasonable to believe that the mean difference between the two values is 0. So if we're saying 0 is a reasonable possibility, we're saying it's reasonable to conclude that there is no difference. And when I say that to conclude that, what I'm not saying we have evidence that there is no difference. What I'm saying is we don't have evidence that there is a difference. So it could be that there's no difference, or it could be that there's a really subtle difference and we just can't detect that. If we have values that are only greater than 0, then we have evidence the first value in the pair is greater, or that the two values are not equal. If it's only values less than 0, we have evidence that the first value in the pair is smaller and the two values are not equal. In StatDisk, we are going to use data on this, and so we will choose the two dependent means, two matched pairs. So mean matched pairs is the specific function that we call on there. We want to put our matched pairs in columns 1 and columns 2. You want to make sure that those pairs are matched appropriately. So for data set 1, so in that column 1, this should be your first value and then the value y that's associated with it. And then your second value from sample 1 and then the value that is paired with it. So these values are together right next to each other. What StatDisk is going to do in the background is it's going to take those values and it's going to take x1 minus y1. It's going to take x2 minus y2. It's going to do all of that in the background so we won't see it, and then it's going to process that information. All right, so let's look at an example. A study was conducted on the left arm and right arm of the same women. Below is the data. Right? So the way that I intend to this data is presented is this is the right arm and the left arm of a particular woman. The right arm and left arm of a particular woman. The right and left. Right and left. And finally, right and left. We want to use a 0.01 significance level to test for a difference between the measurements. So here we want to, the claim would then be, this one's harder to identify. The claim is that there is a difference. So on average, there is a difference. The mean is not 0. And then the opposite is that on average, there's no difference. Now, if you would have flip-flopped that claim and counterclaim, that would be okay. So if you said, oh, I thought the claim was that the mean was 0, that there was no difference, and the counterclaim, the opposite was that there was a difference. That's fine, because it will get all cleared out when you go to your null and alternative hypothesis. So your null hypothesis would then be the mean difference is equal to 0. The alternative is the mean difference is not equal to 0. All right, so we're going to go to StatDisk. So we come over here to StatDisk. I've already entered the data values into columns 1 and 2. We are going to choose analysis. We're doing hypothesis testing. This hypothesis test is about dealing with means, so we have 3 options here. The third of those options is matched pairs. So we have the left and right arms. Those are paired together. And so we choose that. Our null hypothesis was that the mean of the differences was not equal to 0. Our significance level, I actually do not recall, so let's jump back here and look at that significance level. So our significance level, alpha, is 0.01. Right, so that was right up there. And so we have a significance level of 0.01. We are comparing column 1 and column 2. And so now we evaluate that. And this gives us all kinds of information. It tells us the sample size. So there are n, that's the number of pairs. We had 5 pairs. The difference mean, so this is for the particular sample that we had, was the mean difference was negative 72.2. It gives us the difference standard deviation, the test statistic, and critical value. Then we have a p-value that if we round it to the 4th decimal place, that 4th decimal place right here is going to round to a 1. So our p-value is 0.0001. We compare that p-value to the significance level. We observe that it's less than our significance level, so we reject the null. There's evidence of the alternative. Right. So there's evidence that the mean difference, or the mean of the differences, is not equal to 0. So your blood pressure when you take it on the left arm and the blood pressure taken on the right arm, they do not appear to be the same. So we have that. Now we're going to also construct our confidence interval. That is here as well. Negative 91.372 is less than the mean difference, is less than negative 53.028. So I'm looking down here at the bottom, those values right there. So negative 53.028. Notice that these are all negative. So that entire confidence interval is negative. So the first value appears to be less. So your blood pressure in your right arm appears to be less than the blood pressure from your left arm. So that might seem a little bit odd, but if you think about proximity to the heart, it makes sense that you would have a greater blood pressure on the left side as compared to the right side. All right, next time we will take a look at hypothesis tests when we're trying to compare standard deviations from two samples. We'll talk to you then.